This one doesn't work. It doesn't work. Thank you.
Good on the AC. No, no AC.
Is it really cold?
Yes.
The monitor will up together the checklist for which one in, and then our class will begin. Okay. How many students at home? 11. 11? About here, not at home, university. How many? 11. 11.
Yes.
No, not here. in Fulan University. Which year? Last year. Yeah. You huh? You mean here? No. Fulan University? You 80 students? Yes. Yeah. In our lab, there is Egypt. Yeah, Egypt students. Did you want to apply the end the graduate? Anh anh đọc nó anh đọc that student. Yeah, you want to apply the PhD in Giao-thông University in Shanghai. That's me, maybe. Yeah. It's you? The name is you?
No, I don't know.
Okay. So just eight students. 8 students here. In our class, there are 40, right? 40 students. 43? How many girls in our class? 3?
Yes.
Just you.
What's up in the place? Hello.
Thank you. The thank you. The mountain. Standing there. Then there is mountain. Okay. So many students here,
11.
11 in the university, right?
Yes, and the first sheet, no, this sheet is for the first 10 weeks. This is for the next 10 weeks. It's the same list.
The first week, the
First
next,
10. First 10.
first,
First 10.
first, okay. This is for second term?
What?
You mean that this is for the second term? The
No,
first
no, no, no.
term? Yeah, and they are the same.
It is the same. This is for those in school. And here, yes, it's for those home. The first 10 classes. The first 10 classes. Attendance. First 10 classes.
This is the first term. 1, 11, 10, and 11, right?
Okay. Yes,
Right.
yeah.
This is the class. Wait, okay. Got.
That's it then. Innocent book. Or even the one on
Okay. This one?
we have a break time. Send break time. Check.
The time?
Break time.
Okay.
Okay.
Okay, our class is beginning. The welcome to the class. The class name is Interchangeability and Technical Merit. So this is the basic professional class for the mechanical engineering. You are the third year, yeah, to attend the university, right? The first 2 years, you just learn the basic class. In order for the this mechanical engineering, it is basic class, but this is very professional. It's how to read the parts or the drawing of parts from the professional procedure. This is my name is Royuan Chang. This is my email. So just feel free to email me if you have some question. Don't email me after you got the final exam. Don't ask me the scores you got. Okay. So if you listen the class well and learn the class well, you can get a high score. If you don't, maybe you get fail. Okay? Because this class is a little hard. If you listen very carefully, then you can get a high score. You can't. They can't see. You mean the PPT? Don't. Oh, you can hear me. Well, this one. Now this one. Here.
Hello. Too far. Can you hear?
Hello.
Hello. Should be working.
Hello, can you hear me? Online. You can't hear. Hello?
Good morning, Laushi.
This way, where? Oh, come here. Okay, it's okay. This is the APP 学习通. So our class score is here. You can scan this one, and maybe I can send you some information in the 学习通. Yeah, you can scan the picture. Like the PPT, I will send it to the 学习通, maybe in the class group. Okay. And this is about this. This is 学习通. Maybe I can find. Maybe I will to download some information about this course and send it to the 学习通. And you can write or do some exercise. Okay. So this is about this course is mentioned last year it was engineering. So from this semester, you can touch the specialty class. and the total teacher hours is 14 hours. The 32 is for the theoretical class, and the 8 for the experimental class. We can bring you to the tab, to our lab to do the experiments, like to measure, because the name is the technical measurement. You can to measure the parts, the dimension, how to deal with the data, right? So the 8 hours is for to measure the parts or know the measure technique, the measurement knowledge. So maybe you have already learned the course like the technical drawing, the first year, right? Technical drawing, the scenery or machines and mechanisms. This is the second year, right? The mechanical design, second year, right? The follow-up course is machinery, manufacturing technology. Because in this course, we learn the interchangeability, like a procedure of this part, why it is designed, the procedure dimension, and the next course, we just to learn how to manufacture, how to make it, like drilling, turning, and the grinding. So it's the manufacture knowledge. Okay, this is about this course. Oh, what is in the picture here? I don't know why. You see it clearly? Okay. So this is very simple part. This course is not the procedure design. Right, this is the part. This is cylinder. This is cylinder. So you know the value and this value and this limits. Why it is why this is here? Why the values is 0, 1, 0, 2, 1, and to read the symbols or the meaning of the symbol.
Cylinders. Oh. The limits, the 0.021, the limits difference.
You mean this one or this one? Yeah. This is not the hole, this is the shaft, is the shaft. Yes.
Roughness.
Yes. This is the roughness, right? Yeah. The roughness is 1.6, and this is the shaft. This is dimension, diameter, right? So this is the limit. Oh, yeah. This is the limit. So why the word, the value is here. It is. So in this class, we just to learn the procedure design. And also is the interchangeability. And the limit is the same, right? So which one is more procedure? Yeah. Because the best dimension, best is large. So this is more procedure. So in this course, we just to learn how to check the words. This is the standard. It's not you want to write or to design what it is. So this is okay. And in this course, we just learn to write or draw drawing, to learn the drawing, and also to read the drawing well and know what is it. And this one is, yeah, if much more complex. Right? This is very basic part. This is shaft. Right? So there are some values like the simple or the values like 5, 20, F, 6. So what is the F? The meaning, right? And this third is 5, 70, K, 6. What is the difference? Like this is key slot, right? To assemble a gear or something, right? A gear here. So this is 40 long, and this one is 5 and line, because in this slot, the key slot, we a sphere should ascend it. So what kind of the dimension we design it can't assemble a gear. So what kind of a gear to assemble here? Right? So in this course we learn this. And also this is roughly is 1.6. So why the value is 1.6? What kind of the word we choose? This is F, and this is K. So why it is different? Right? So in this course we learn this, and in the final result, maybe we give you I give you a shaft, and you need to write the symbol and the word. Why do you to write it like this? So which one is right or is wrong? Okay. So okay, the goal. And leave so far. So the goal is to understand clearly the concepts and the effects of interchangeability. So understand the standardization and the measurement technology. So the measurement technology is just a little part of this course. So in the course, we mainly learned the interchangeability and standardization. So what is standardization and what is interchangeability in this class? And also to familiar with the basic content of every tolerance studied in this course, to know exactly the basic terms in this course. There are many terms. In many terms, so we need to know exactly like what is the tolerance, and to analyze the fit properties and fit type. You read an assembly drawing and to draw the size, tolerance, and the figure like so the fit that is the clearance fit, like because like this part, right? Like this part, this is the shaft. You can assemble a hole, right? So the clearance hole, the clearance fit like the this is a shaft, and this is a hole, and this is a hole, right? So this is the procedure, like this is the hole is here, like this, the limit is here. This is the clearance. This is a little clearance, right? and also the fit properties, and also the interface. Interface. Like this, the hole is here, is like here. The shaft is here. So in this, we have to assemble it very tightly and to, so this is can't rotate. So for the clearance, it can rotate it very, it can rotate it well. And for this, it's for interference. So it cannot rotate it. It just to collect it well, and in order to rotate. And another one is transition. Transition is like it's between the clearance and the interface. So sometimes it can rotate, and sometimes it can collect it well. So this is the types. We will learn in the later. So how to choose this one. And another girl is during the read a detailed drawing. Detailed drawing. Oh, thank you. To know exactly the procedure requirements about size, form, orientation, location, runout, and surface texture. So that run is surface texture. The runout. It's like this is a this is a shaft. It's like this is a shaft. It can to rotate it very quickly. The rocket, if you want to make sure it work well, so the runout it can rotate. So it can rotate. It's not so well. It's like to shaft. It's like to it have some runout. So you need to make sure the runout is limited. Is a little like 0.002 UN. So it theoretically it can to this is circle, right? So the it's reality is like here, right? Because it rotates very quickly. So this one is 0.0 UN. So it's to make sure it is here. So it is just to available. And the location and the orientation, something of size and form. Also calculate the limit of size and describe the form and orientation, location requirement for every feature to draw the dynamic tolerance. The runout is the dynamic tolerance of the figure, right? And during or engineering drawing, assembly drawing, and detail drawing to indicate the procedure requirements on the drawing correctly according to the standards. I give you. Give you this you this word, this part, you can to read it. Okay? Read it and know what is the meaning of the symbol. And then you can to make it, right? So this is the text, the book. I sent them on in the group, class group. Yeah, in the class group. This is the book we use in the class, the fundamental of geometric tolerance and measurement technology. The name is different, but the content is the same. So this one is a reference book, the fundamental of geometric dimension and tolerance. So in this book there are some figures. There's some value figures in here, and how to you learn to know how to read it. So this is our agenda. Its total is 40 hours. And it's a closed book exam. Close the book exam and give some questions. The homework and attendance is 30%. 30%. Experiment is 10%. The test is 60%. So this is our agenda. The chapter 1 is introduction is 4 hours. And chapter 2 is limits and fit. It's like the fit, like this one is fit. And limit, like the first figure, that is the limit, is 0.041. That is the limit. And fit is 8 hours. This one I think is important and a little difficult. So the chapter 3 is geometrical quantity measurement. It's 4 hours. So we just know very simple. It's simple. It's very simple. The data, the data deal with the technology. You mean that this is a part you can choose. This is the part, right? You to measure the straightness and then get some data, right? So you need to distinguish which data is right and which data is wrong, because you measure this straightness. Maybe the measure technology. You don't use you use the wrong measure technology, and you get and you learn to delete it. So you should know which data you should delete, and which data is useful. So this is chapter 4. Chapter 3 to learn how to measure, how to deal with the data. And chapter 4 is geometric tolerance. So this chapter is very important, and there are so many contents that we use 12 hours to learn it. And chapter 5, we learn the roughness. So what is the roughness? Why it can produce why does it produce the roughness? And then how to sign it, right? The roughness. And the experiment is 8 hours. And the test is 2 hours. This experiment will we can to collect the teachers in the lab and to arrange the time and tell you to do the experiments. Okay. for students who are unable back to school, just to read the book carefully and also listening the class and watch record the video. So finish the exercise of each chapter and answer them in the app. So for some exercise where I ask you to do in the class, or some exercise I'll send them in the 学习通 as the homework. So this is the chapter, the introduction, interchangeability. So I will give you a video. Which one is the interchangeability? Interchangeability. So why is it so important? We can hear you in the no word? No word. Huh? No word? No sound? Here.
always.
Did that
being produced on a massive scale, impacting the entire product. The whole process of making goods became quicker. This was added to parts are components of machines that are mass produced identically. This technological innovation was introduced by Eli Whitney, who is also the inventor of the famous concept. After Whitney became involved in the manufacture of firearms. That year, he had received a request from the government to produce 10,000 muskets within 2 years. The contract between Whitney and Oliver Ellsworth, the Secretary of the United States Treasury at the time, verifies the very deal that led to the invention of it. This technological innovation was introduced by Eli Whitney, who is also the inventor Interchangeable parts are components of machines that are mass produced identically. This technological innovation was introduced by Eli Whitney, who is also the inventor of the famous cotton gin. The idea of interchangeable parts arose in 1789, after Whitney became involved in the manufacture of firearms. That year, he had received a request from the government to produce 10,000 muskets within 2 years. The contract between Whitney and Oliver Ellsworth, the Secretary of the United States Treasury at the time, verifies the very deal that led to the invention of interchangeable parts. However, Whitney soon realized that the traditional method of manufacturing small arms would not help with processing the government's request on time. Because an individual was responsible for the entirety of the product, the need for specialized and individualized work and skills demanded much time. Also, due to the uniqueness of each product, it was hard to compare a part of the machine with that of another, as there was no standardization among products of the same kind. To resolve these issues, Whitney devised interchangeable parts, which greatly affected America during and after the market revolution. Interchangeable parts brought along important changes to the manufacturing system of America. Because individuals were now focused on only completing one task instead of creating an entire product, the whole process of making goods became quicker. This was advantageous to America, as during times of war, America could quickly manufacture arms, which played an important part in national security. Moreover, the goods were now all standardized, meaning that they were of uniform size and shape, and that a component of a certain machine could be used for another machine of the same kind. This made it easier to repair goods as well. Due to the fact that goods were being produced on a massive scale, the price of goods also became more affordable. Because standardization of goods led to a more homogeneous society, the quality of goods were now guaranteed to the consumer, meaning that they did not have to give up the quality of a good for a cheaper price. Thus, the standardization of goods led to goods getting cheaper, positively impacting the American economy, especially for consumers. On the other hand, this kind of mass production led to descaling among the workers, as they were only expected to work on a certain part of the machine, rather than meticulously crafting a product of their own. This caused a cultural shift from a skill-based manufacturing society to an efficiency-based system, where individual skills were not as highlighted as they were before. The short-term effects of Whitney's innovation was that the economy of America could thrive as it could export more goods quicker, could suddenly repair goods more easily, and could provide the muskets that the federal government has requested faster than any other country. These short-term effects also affected the long-term effects, allowing America to continuously produce goods at a quick rate and support the national economy. However, the de-skilling of workers, which could have been overlooked during the revolution due to the invention's novel qualities, resulted in high unemployment rate in the status quo, as more and more companies turned to mechanized labor to produce goods. Still, the introduction of interchangeable parts has brought good long-term effects to the American society. Here are some examples of how Whitney's invention of interchangeable parts made a lasting impact to the American society. On the left is a machine made from using interchangeable parts. On the right is the well-known assembly line of Ford. It is reasonable to say that interchangeable parts acted as the precedent for the assembly line, as the line was also aimed at fast and efficient mass production that guaranteed good quality goods for a cheaper price to the customer. To the present day, America relies on the same kind of manufacturing system to meet the demands of the consumers, and it is through this system that more people can have access to affordable goods. By examining the role that the interchangeable parts play in the American society and the changes it brought to the manufacturing system during the market revolution, it could be said that Whitney's invention of interchangeable parts positively impacted the American economy and society since the market revolution, allowing the United States to advance technologically. Although not explicit, what is interesting about the introduction of interchangeable parts is that it emphasized the idea of time in the American society as manufacturers aim to produce high-quality goods at a quicker rate. The introduction of time was fairly new to the workers, as the workers were no longer receiving wage based on how much they have accomplished, but rather how many hours they have worked. In this way, interchangeable parts affected the American society in a whole new way. Also, interchangeable parts allowed the mass production of mechanized devices, and this contributed to the soon-to-be revolutionized American industry.
Okay, could you tell me what is the interchangeability, and what is the advantages? What is the advantages of the interchangeability? Yeah, when you read, you see, watch the video, you know. Yeah.
The ability to divide the workload of a particular machine parts, where different people develop different parts, and then in the end they are assembled.
Yeah.
And the advantage is that you can produce more since different people are working on different parts after they have been assembled. Also, you can work at a cheaper rate because who work on different parts, they are assembled.
Yeah, because it's cheaper. Yeah, the cost is low. And the effective efficiency of the production is higher. And also as the first picture, who uses the interchangeability? What's
And Whitney.
yeah, and yes. That is he created the interchangeability. So that is why we learned the interchangeability. Because it makes the is the productive for the company, for the manufacturing, the cost is low. Yeah, that's good. So this is the rifle, because American military give the any widely is 10,000 rifles he needed to make. So it make just give him a short time to make the gun, the rifle. Yeah, and before it widely to make the rifles, just a worker just make all of the part of the rifle. And it makes a long time, and another worker to make a different the rifles. The two rifles, the part cannot change. It's a part from the another worker. The part cannot to assemble in this work in rifles. So it makes a long time, and the only widely to have a good idea just to one worker to make one part. So he's familiar with the part, and another worker to make another part. So all of the part, the limit of the dimension limit and a little, just have a little change, so they can to assemble it well. So that is the interchangeability definition of the term. You understand what I say?
Yeah.
Okay, so this is the beginning of the 19th century. This is the story of the rifles. He received an award from the US, the government, the 1,000 rifles, okay, which he had to manufacture in a short period of time. So the components of each rifles were made separately by different workers. So beware, the dimension of these components were kept with a certain limit. That is very important, right? Because you just make the component with a certain limit, they can assemble it well. If the dimension is not in this range, you can't to assemble it. So in our class, just to a certain limit. What is the certain limit? We need to learn that. So this is namely interchangeability and fit. So the performance of the and the cost of the production of the production is always considered by engineers or designer and the manufacturer and the inspector, right? Because for the manufacturers, he just procure the cost is very, very low and produce many parts, and they can to make money. So however, usually the performance is higher and the cost is higher. And at the same performance, the cost and then the competitiveness in the market is low. How to ensure the production with high performance and low cost is a key problem for the engineers. So one answer is to design a mechanical components with interchangeability. So in our daily life, so there are a lot of the devices with interchangeability, such as when a bulb is failed. So when the bulb is failed, we just to make it from the store and can to assemble it. So at the same time, the screw is the same, right? I mean that the diameter and the diameter is the same. So there is a standard, right? If you are a manufacturer, you just make a bubble. The diameter is different from others. So if the bubble is failed, the bubble you manufacture product is failed. I just to make the same bubbles in your in your manufacture. So I mean that the bubbles, you can't to, and some people cannot to want to buy your bubbles because your bubbles we just use the bubbles from your company. Yeah. So that is the standard. So we should learn the standard in standard information. And also the light can be continued service for us. The component in the basic of watch, this is the daily life. This is the basic, the wheel is failure. We just need to buy a wheel and assemble it. It's very simple. And also the steel in the watch is broken. We just need to buy it and to assemble it. So we can use it again. So this is interchangeability. And also some country should have the standard. And for the engineering or the mechanical engineering, there are more devices with interchangeability. And show in the figure that this is the engine. So the gear, the launch or the screw or something, the small part also have the standard diameter, right? The bearing, the rolling bearing are also the manufactured and assembly according to the interchangeability principle. So what is the interchangeability principle? So interchangeability is just one product, process, or service to be used in place of another to fulfill the same requirements. It means that this is a part and another part. If this part is failure and we use another part, it can to replace it. No, without repair. In the mechanical engineering, interchangeability reference to fabricate workpiece respectively according to a specified tolerance of geometrical, physical, and mechanical performance parameters, and then during assembly and repair work, such workpiece can freely replace it another. Further machining or round out another. Without further machine or caster fitting, it means that this is the part you just take it and to assemble it without machining or caster fitting, right? So it's very simple. So also the interchangeability in one workpiece has two aspects. One is the functional interchangeability, and another is the dimension interchangeability. The function interchangeability, like the stress, the stiffness, and the hardness, and the materials properties, like the stress, stiffness, and hardness. If this material is broken, just use another material. They have the same stress, stiffness, and hardness, so they can change. And physical parameters like the valve, rotate speed, and lighting, that is belong to the function interchangeability. And the geometrical parameters such as the size, the form, and the surface texture. Like we say the bubble, they have the same size, so they can interchange immediately. So dimensional interchangeability is concerned with geometrical properties. They have the same size, right? In the course, only the dimensional interchangeability are discussed. So in our course, we just to talk about discuss the dimensional interchangeability and to learn the limit and also the fit properties. Yeah, this is the advantages. There is another video to see it. To see its advantages. It's a very short video. Let me see. This to assemble the part very quickly. No. Change what?
Repeat.
A repeat. It's very short time to change it. Yeah, this is to assemble the car. The race is very quick, right? Just the seconds. So for in Japan, they produce the car, the Toyota. I remember the Toyota. The Toyota just give them 1 minute. They can to produce a Toyota. Oh, Toyota. 1 minute, just to assemble it. Yeah, assemble it very quickly because the parts are standard, right? So this is the interchangeability advantages. The interchangeability allows easy assembly of new devices and easier repair, right? Because all of the parts have the same size. All this not very exactly same size. The size at the limit and the later range, so can assemble it well. And the time and speed required of the person doing the assembly or repair, and that the one person or one work just to do this step, right? This step, so he just familiar with it, so can to operate it very quickly. So if the machine element is interchangeable, the machine element can be used as possible as it can, and it's designed as standard workpiece and common workpiece, then they can be manufactured as much as possible. So as for us, so we just to learn the standard the site standard principle and design the part with the standard information. Okay, this is the advantages of the interchangeability. The design, for the design, so withdrawing and calculating jobs will be decreased because the part is the standard. And the designing time is saved and the computer added design can be used, right, with the computer added like the SolidWorks, the SolidWorks, yeah, and Pro-E or the CAD to draw the part. The manufacturer, the large numbers of standard machine elements can be made. Yeah, right, because you can to make it very quickly. The efficiency is very high. The cost is low. And the distribution manufacturers can be adapted and the automatic manufacture lines can be used. This is the automatic manufacture line, right? It's quickly to assimilate. And the result to the cost of this standard machine element is low. So for the repairing, it also is good. It's familiar and simple. The machine element can be replaced as quickly as possible when the machine element is interchangeable. So the repairing time and the cost are decreased. So like the watch, like the bulb, if it's broken, just to buy it from the store and can to assemble it, it can reuse it again. Where whole machine has more efficiency and a longer life, right? Some part is broken just to change some part. The left of the part have still used. Yeah, this is this car. So you have a short break or continue? Huh? Break. Okay, a short break. How long this? About 12 o'clock. We can end our class. Break 10 or 15, 30.
Oh.
Okay, you can get our back in the 10 o'clock. I remember you live in there is here in the US. You are yeah, we have this one, right? You got yeah, by the time you put it into the solution. Yeah. So how do you? Yes, I keep like that. Let's keep one and not keep that. Champion. I remember that. Next time I will come to you. Eh? Why did it what up? Why did they want a food? That she what it means is here. Yeah. Yeah. This is good. It's not true. Yes. is very simple Chinese or just community Wait, I remember you. There's a little you
My
Give me the clock. Let me see, let me see. Ready? It's up. Which is mine, and me. Oh, this is back here. Clock two, I think. Oh my goodness. They belong to you, the monitor, you know what I mean, it belongs to you. It's not you, you know, this group too.
We are spring and fall. Either you join the joint stand up and you join with yeah.
Okay.
We have two different teachings.
Different in all of green and the warm. You are warm.
They are
Ah,
they are mixed together.
obviously. You are still. I think this child name is very hard. Yeah, this name is easy. I think it's from right, the lady.
Share what?
Is she? Yeah.
Good.
What? That doesn't mean it's in public. You're insane. Well, not me, you know. Yeah. Where do you see? Where? Sure. Okay.
Mais c'est devenu trop devant comme ça. Pourquoi? C'est devenu trop pourquoi? Tu as compris ça? Ok. Passe le téléphone. Passe le téléphone s'il te plaît. Pardon.
Oui.
一下就五，这个不是在你的。
That's my now.
Aqui a gente tem que se você falar com as pessoas, eu peço que vou te sair. Lá onde é?
I'm just on the side. No.
Não tem essa aqui.
Yeah, side.
Não está nosso
My Chinese name okay. They got sell it. Sell it. My bro.
Ah?
My solution.
Ah,
Mas a gente faz o que
Yeah, bro. Solution.
Tá bom.
Yeah.
This is the family name.
Yes.
This is
Chinese name is same my father's
What's the name? This is the
Send
And then this is your father's name. This is your name. This is your name. Oh, this is the family name.
Maybe you can everywhere.
My Chinese name. Yes, my Chinese name changes.
Ma.
Yeah. Chinese name is Mom.
She's not on my Chinese name changes. Yeah. She gonna
Change music.
Yeah. Change song. Let's change song.
Sorry.
It's okay, but she don't know.
This one doesn't have this kind of check.
What do you have?
Bro, what do you mean? Oh, is it so much? No, I jump here.
He's
Yeah.
he didn't know that we have physical class today. He thought we have online.
No, Saturday.
He thought maybe we have online class.
Absolutely.
That's why he didn't come.
It's not difficult.
Because now she sent the message.
In the morning. You will the teacher phone.
Yeah.
They won't buy
In the morning, no, yesterday.
What are they?
I said this actually it was updated yesterday. Last
Update.
From class yesterday.
You know, she sent a message.
He told me, but she's coming back. Yes. Tell the class. Today. And the narrow side.
First,
This guy is that. But it's not the nonsense. No, but you're not the nonsense. Guys, who are we? Us? Who are we? The first is the family. No, actually, this guy is different. By China is supposed to be like that. Actually, don't forget this guy's lava, Juju. Yeah, lava, Juju. Just that's lava. Jama.
This is the family name?
Yes.
So this is the your name?
Yeah, no, my name is Juju, guys. My name is Garcia for you.
Garcia.
Yeah, Garcia. Lava.
That's the
It's covered.
online.
Online, yeah.
Yeah, it's a. It's
Uma, it's coming, it's not, it's not. We went out, no, it's here.
Oh. This channel is good.
Yeah, yeah. And he's a son of Jumbo, it's a son. It's a son of Jumbo. Son of Jumbo. Oma.
Oma. It's Oma.
Yeah.
It's family. Egypt.
You're actually seeing lava. You walk on the fire. I'm not saying, I believe it's difficult to apply it. I'm not saying yeah. Well, I should find it difficult just like it's fine. No, on
Innocent. There. She.
Yeah. All of us know me like
Mom. No, pasa. Mom.
袁强，袁
no,
no，
Aquí está.
袁强，
No,
yeah.
Ya Chloe, pero no es Chloe.
Yeah.
Okay, okay. I think the maíz.
Yeah, somewhere else. Mujala. Yeah, Suma. That's you. Suma. Bring what Mujala. Mujala. Sounds yeah. Lava. Bro. Yeah. Did you find it?
Yeah, I found it. But it's not bad.
Where?
The subscription.
No,
Yeah.
you are lying.
Okay, then. So,
You should enjoy yourself. Should enjoy yourself. Yeah. So no more, no problem. Someone, my baby. But what do you want to say to me? Don't send me nothing, son. Also, you are searching my name. I saw the laugh. Don't send me nothing. Absolutely nothing. Are you want to see me something?
I don't have to send you some.
Oh, you should enjoy it. Awesome. They say, I'll give you more time. Explain de Barcelona. No. She's there. She's there. I think that getting with cameras. I guess so.
Class. Not class. Guys, looking. It's Muhammad. Say.
Did you have something?
Yeah, me too.
That's cool. That's not.
Stanley. You name it. You have to be there. Yes. You're right. Okay. Yes.
Yes.
Right. Yeah.
Yeah. Yes. Yeah.
Well, check the name. It's 24, okay. Awesome. Right, you. Yeah. Take the online. Who is here? Not here. Did you write the unique number?
The numbers.
Yeah. Let me
51. 51.
tell them. 32.
51. 51.
They're here.
Okay, okay. Yeah. Philip.
053 051. And this is aham.
Email.
Email is here. Okay. Easy. He said he's a monitor, right? Of the class.
No, we have two monitors.
Oh, yeah, you are two. And 0 line 4.
4.
And 0 6 4. 6 6 0 6 6. And 0 3 3. And 0 3 4. And 0 1 line.
9.
1 line. 0 6 4. 0 0 4. 6 6 4. There are 6 6 0 0 line. 0 0 11 0 11. 0 11 and 0 8 0 0 8 and 0 17 17 7 0 0 7 and 0 13 3 0. Okay, that all. Taste, not taste.
Student numbers. That we tell them student numbers.
Oh, student number.
Tell them unique numbers. They might not understand.
Student. Okay. Zero line 4.
Yeah.
Go here.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, man. That's 23.
23. I don't know because it's the lane.
I just know. I look at it.
Okay.
I see them.
It's hard to find them and they are with the lane.
Yeah.
So I'll change this.
Okay. Yeah. Alexander.
You like science.
It's okay. After the class, we'll
Okay.
see them again.
Yeah.
Thank you. Okay. Thank you. Okay. Back to Fit. Continue our class. We just learned the term of the interchangeability. The classification of the interchangeability. So interchangeability is classified two types. The first one is complete interchangeability. So in an assembly or any auxiliary options and their repair are not needed for it means that this is a part and this is a part. You can take it and to resemble it well. You don't need to repair it and you don't need to choose it. Right? This is completely interchangeability. Right? So in incomplete interchangeability, so is a assembly in assembly of selection of a grouping before assembly and adjusted during assembly is permitted. It means that you can produce a large number of the parts, and then you choose a part to assemble another part. So it costs time. It's a time consuming, right? Yeah. But for in this type of the interchangeability, I mean the limit. So this is the part, right? So for the complete interchangeability. Like the limit is the value is limited. Maybe is here, right? Is limited. I mean, the part, the dimension is here to here is available, right? And for the incomplete, this part it can to change a lot of parts quickly. You don't need to choose the part to another part. But for the incomplete interchangeability, I mean the limit is large, right? It's larger than the complete, like this one, right? So the dimension, the part dimension is arranged here, right? So you can choose like the small hole to assemble the small shaft. In this condition, the cost is low because the limit is higher, the cost is low. And for the complete interchangeability, the cost, the manufacturing cost a little higher than the incomplete interchangeability, right? So, and this is used in the workpieces are assembled and machined in the same factory. Because in the same factory, you can choose one to change another one. But for different factories, because you don't know the part, you just to take it and to assemble it quickly. And example, I mean, like the group example, the group incomplete interchangeability is an example. Like if for the company, it produces a barrier for the head of the barrier. So the size is like this range, and you just use a shifter, then the shifter. Like this is the head, right? And this is a shape, the shape is a shifter. Like this hole is a hole, and the hole, and different holes. This head use the shift the hole to put in the shifter. It can to down. They have the same size. Do you understand? And if this hole is larger, and then to set this head to use put in the large hole, and the hole can to down. So because for the barrier, this is the same, completely same size, right? But this one is I mean that this size a little larger than this one is okay. But for the same barrier, the head are completely, not very completely, only completely same. So you can to rotate it very well. You cannot to wear. Yeah, without wear. So you can to rotate it quickly, right? So this is incompletely interchangeability. For the manufacturer, they use this technique to decrease the cost, right? Because this limit is larger, so the cost is low. So the incomplete interchangeability is adopted only the assembly procedure is very high, but they use a different technique to decrease the procedure, like this the system. And it's hard to fabricate or very expensive to fabricate or even not able to fabricate. This means that if the limit is very low, the cannot to fabricate the designer to make the limit higher, and they use the group interchangeability to choose the size, to choose the parts. So in this case, the tolerance of the workpiece is specified bigger value, like this is the limit of the tolerance, this one, tolerance. The tolerance, it is tolerance a bigger value, right? During machine these workpieces, and after fabricated, the workpieces are grouped according to the actual size through the measure. This measure is used the system is simple, and some use the caliber or some automatic device. So the difference of the workpiece actual size is very small in the same group, right? The same group, the limit or the tolerance, the difference of the workpiece is small, right? The same group. Then the workpieces are assembled according to the corresponding group. It's like this one. This big holes fit with the bigger shaft, and the small holes fit with the small holes. So this group, the incomplete interchangeability is used in the complete, so you can to decrease the cost. So this is the example. Yeah, this is the definition of the interchangeability. So the first one, what properties should be with if a component can be called interchangeability?
Size limits.
Yeah, same size.
Standability.
Yeah, still, yeah, standard. So they have the interchangeability. They have two groups: is complete interchangeability and incomplete interchangeability, right? Incomplete changeability, they have a big tolerance, but for the complete changeability, it's a small tolerance. They have the same size. So what are the advantages of interchangeability? After you before we discussed the interchangeability. The cost is low.
Efficiency is high.
Yeah, efficiency high. So you can assemble the car very quick, right? Another term is standardization. Because this part and this part is interchangeability. So they have the same size, right? So who can give you the same size? If you are a designer, you say the size is 1 millimeter. He said the size is 2 millimeter. So they are complex, right? So they have a standardization. The standardization is defined by ISO Guide 2. This is a story. Definition as the development and implementation of the concepts, doctrines, procedures, and designs to achieve and maintain the required levels of compatibility, interchangeability, and commonality in the operational procedure, material, technical, and the administrative field to attain interoperability. So standardization is one of the important means of modern organization of production, the premise of the professional collaboration of production, an important part of scientific management. This is a collaboration. Because you buy a part, like the Toyota, or like you assemble a car, you buy part from one manufacturer and buy another from another manufacturer. So they have the same standardization. You can do assemble it well. So that is collaboration. A standard may be developed privately or unilaterally, for example, by operation, regulation body, military architecture. Standards can also be developed by groups such as trade union, trade association. Standard organizations often have more diverse input and usually develop voluntary standard. This might become mandatory. Yeah, this is mandatory if adopted by government, business, contract, architecture. This is the mandatory. The standard is published either to obey, not obey, either to follow these rules, right? Follow these rules. This is GB. This is the Chinese standard. It's published by China, and this is the sign, right? This is the sign you can choose code when you see this sign. So if you forbid this one, so you can get a fine, right? And this is the way to. I mean that this the way is standard, right? And in mechanical industry, that this one is daily life standard. So this is mechanical industry. The parts should be designed and fabricated according to certain standards. The ISO. This is International Standard Organization. Okay, I have a video is about the ISO in our daily life, in the mechanical and the manufacturing. The ISO is used everywhere. What is the ISO do for us?
For incredible opportunities in endless possibilities. But it can also be a complex and overwhelming place. When things don't work as they should, it often means that standards were absent. But when ISO standards were removed, life is just so much richer. ISO standards help to make the world a safer, clean, and more efficient. From food safety to computers, from healthcare to new technologies. There are many challenges facing the environment, economy, and society. ISO can make a positive difference to all of them, utilizing the wealth of international experience and wisdom. In today's ever-changing world, ISO standards help create growth, open up global markets, trade fair, including for development. ISO standards can help tackle global challenges like climate change, road safety, and social responsibility. ISO standards touch almost everything we do, keeping us connected and entertained, staying productive and creative, sharing ideas, promoting innovation, and keeping us safe and healthy. ISO is the world's largest developer of voluntary international standards. With over 18,000 standards for nearly every aspect of technology and business. For over 60 years, a network of standards bodies in 163 countries, working in partnership around the world and livelihood. ISO builds confidence for today, for tomorrow, and for the future.
Yeah, so the International Standard Organization exists everywhere, right? So
And class.
do you have some question? Okay, and G national standards of China. This is GB is actually is read 各部 national standards of China. JIS Japanese in industry standards. ASME American Society of Mechanical Engineering. So
So all these ones, do they follow, is there any hierarchy?
this is, I think that if we to attain the international trade, so I think all of this is the China or the Japanese or the American is follow the ISO, and also they have their unique standards for the people, right? In their country. So just to follow the ISO, and then they have their themselves the standard. In this book, the fundamental GPS geometrical production specification standards and some complementary GPS standards are introduced, like the limits and the fit. ISO 这个 2860 standards. So that means I send you the book, and I see that we need to check the table. We have the standards, so there's the table. We have to check and then know the limits and fits. Geometrical tolerance, the ISO, and the surface texture, also ISO. This is information. The rolling, bearing, radial tolerance, and the cylinder, gear, ISO system of accuracy. So all of this information is from the ISO, because nowadays we just attain the international trade. The standards are follow the ISO. So this is ISO information. This is published 2010, and this second one, this is a new one, is published 2017. So you just know there is information, and we use it just to check it. So what is the standardization?
The process by which industrialization a standard or fixed value or limits machine parts.
Yeah. Yeah, the ISO is published the standards. This is a definition, but you say it is right. I think it's the same side, same is the means of model organization to publish this information, right? Management, this is the standard. Okay. And the third one, the term is a series of preferred values. So, the ISO, why the ISO publish these values? This is the range, right? If you want to loosen or tighten a screw, you want the range to tighten or screw it. So what kind of the what kind of size of the dimension you choose. The range is not like 1 millimeter, 2 millimeter, 3 millimeter. No, this is so very, very complex. Just it's 1 millimeter or 10 or 6. The value have done regularly. So in this part, in this section, we just learn how to define or how to how to choose the right values. They have some principle or some rules. This diameter or the size is followed the series of preferred values. Okay, this is the story. It's like this how to publish the preferred values. So in the 1870s, was the army officer, the French. This one, column Charles relax.
His friend.
You know him?
Charles. Charles.
You know him? You know him?
This guy was Spanish friend. Charles, we are speaking English. Serious words in English.
How to say Simon in French?
Why would you say Simon in French? What's in English? Charles.
Charles.
Is it French name?
It's French name.
You write it in French.
Do you know his name or do you know his story? He's the guy who published the preferred values. Huh? You know his story? Okay. He derived, okay, be quiet, okay. Continue our class. He derived a preferred number system. Yeah, the relay followed his name system using a geometric progression based on the number 10 and the 5th, 10th, 20th, 40th, 80th, the root of the 10, right? Rounded off of 1 or 2 decimal places. Created the R5, R10, R12, 20, 40, 80 series. So when we design a part, we just to follow this one, like the cup. The diameter is not very ornamental or random. So you can follow this preferred values as a designer, a manufacturer, as a designer, right? Mechanical designer. You should know this one, and you should check the values. And it's a basic series. And this R5, R10, R20, R40 are the basic series. And R80 is the additional series. In this section, maybe in the final exam, there is 1 or 2 questions about this one. Okay, just listening carefully. So the reason, well, it is possible to buy custom passive components with any desired value. Standard parts are manufactured in ranges of prepared values. The reason is that the manufacture method of many components results in a spread of characteristics, and it is expensive to make or select the accurate values. While most components will work adequately with loose tolerance parts, it may good economic sense to make the and store only a limited range of values. Okay, so this is the reason why we need to use the series of the preferred values. In industrial design, preferred numbers, also called preferred values, are standard guidelines for choosing exact product dimensions with a given set of constraints. It means that the ISO published the standard, right? It's not very, if you are an ISO, you just to publish a standard of rules is not very rounded. Rounded. Yeah. You just to follow some rules. Yeah. So this we learn the rules, right? Product developers must choose numbers, lengths, distances, diameters, values, because there are so many values, so many lengths or distance here. So how do you choose the words or the values? Well, all these choices are constrained by considerations of functionality, usability, compatibility, safety, and cost. So there usually remains considerable leeway in the exact choice for many dimensions. So using preferred numbers increase the probability of compatibility between objects designed at different times by different people. Okay, you can see. In other words, it is one tactic among many in standardization, whether with a company or with an industry, and is usually desirable in industry context. The operator motive can be applied. If it is manufacturer financial interest, for example, manufacturers of consumer products often have a financial interest in lack of compatibility in planned obsolescence and its selling name, brand, and model specific replacement parts. And they are chosen so that when a product is manufactured in many different sizes, they will end up roughly equally spaced on a larger remake scale. So all of this was just to give us the larger remake scale. So with this scale, we can contain all of the values, the dimensional values. Therefore help to minimize the number of different sizes that need to be manufactured or kept in stock, like this one. So this is important, okay? So this is the theory. So how do we use this theory of previous values to contain all of these the values? So we can follow the rules. The series of the preferred values are the segment, geometric series, and their comma ratio can be calculated according to the equation. So this is R5 series of preferred values. R10, it means that this is the Q, like this one, the R5. The most basic R5 series contains of these 5 rounded numbers, like so R5, for example, R5, the first one is 1, and the Q is 1.6. So it's multiply 1.6, right? This is 1.6, right? And also this one is also multiply 1.6. This is about 2.56, right? This around it, so it's like 2.5, and then to multiply 1.6, right? is almost to 4, and is almost to, and it's multiplied 1.6 is 6.3. So like the RT it's like the RT theorem. RT. So this is about 1.25. So the first one is 1.5, right? If the first dimension is 1.1, so the second is 1 multiplying 1.5. So it's almost 1.5. And the third one is 1. Multiply 1.25. So it's about what? The table. It's almost it's around 1.6. Yeah, so the third one is 1.6, and then the 1, 2, 3. The fourth one is also to multiply 1.25. So this is the series of the right? And the same, the R20. So this is the 1.12. So if the first one is 1, the second one is 1.12. The third one, this is 1.12. But the 1.12 is about is around of 21, around 125. Around. So like let me see is R5. The R20 contain R10, right? Because this is 1, 3, this is 5 is here, and it's 1.25 multiply 120. So it's around 1.25. It's 4, and also around, not exactly, and also is 1.6, right? So this one, this R20 contained R10. So this, if we choose this values of the series of the values, we can choose more the values. Also, the R40 is 10. This is 40. This is 40. So it's 1.06. This R80. So this series of values contains all of this one. But when you design something, you design on this one, so the dimension, just the values dimension, just to choose, follow the R10, R5, R10, R20, the values. So this is the table. I mean that we can calculate the word like this one, You multiply the cube, right? But this word we just to check in the table. This is the standard, the ISO standard. So you just from the table. If you want to design a cup, a cup, you just use a R10. So the diameter is like the 25. 25 or 30, 31.5. Just choose the word in here, or 40, or 50. You don't need to use like the 41, 42. No, that's standard. Right? You choose the word in here. This is standard. Because when you want to replace some part is broken, you just to choose one to change it.
If I take R20
R20
and then I use a diameter of 4.
Diameter 4.
Yeah. How can the person tell whether I use R10, R20 using R20?
Even the difference.
Yeah.
Right. I mean that if you, let me see. You want to make a part that have small, the limit. Let me explain how to explain that. You need to make a part, like a part. The part 1, part 2, the limit, the diameter or the size is very close. Like 1 and 1.525, very close. You just choose the R40 or R80. If you choose, you make the part like if the cup, just the ones 10 or let me see. It's 20. It's large one. I mean that you don't you like maybe like a small part. The small part is very small part. So the limit, the diameter, this one and the next one, so it's close to very small. So I use the large, like the 40 or 20. The series. If you use the part is very large, right? So the first one, the second one is large. So you do the R5 is like the 25 or 40. So this is not, this is just 1 to 10, right? 1 to 10. But this theorem is can to it drain to a non. You mean for example, for example. This is R5, right? The first one is 1, and the second one is 1.6, right? This is 2.6 is 10. So after the 10, is another one is multiply 1.6 is another 15. Right? 15 and 15 and 25 and 40.
Yeah.
So it drain very large number.
Also, my question was that like this is R40 now.
Huh?
This is R40.
Yeah. R40, R20, R40. Yeah.
If someone uses this, you can still call it R5.
Exactly. Oh God. And this you mean that it's called R5 or R20
or R40.
It doesn't matter. You need to choose the diameter to design the part. Right? So this is the standard value. So if the diameter of the size is close to very well, it's very close. You just use the R20, R40 is to the range. This is large, and use this R5. It doesn't matter. If you to do 10 is belong to R5 or it belong to R10, it doesn't matter. You just choose this is standard word. It's okay. Like this one, for example, this is R5, right? R5 previous series. So if our design contains tell us that the two screws in our gadget should be placed between 32 millimeter and 55 millimeter apart. So what size of the screw do you design? The diameter. We'll follow the R5 series, R10, R5 series. R10 is the same, I think. Which size do you choose? Choose the size. This is diameter. This is diameter, right? Or this length. I think it's the length.
Actually, the 32 is actually the
It's a
distance.
four, actually it's four.
It's 4.
Yeah.
But here, I mean this, yeah.
It's 40.
Yeah, got it. Yes, that's right. Do you okay? Do you?
The constraint said the screws gadget should be placed between 32 and 55
Yeah.
millimeters apart.
Yeah.
Apart.
Apart. Is this the length? Is this range? You have to choose this length. I mean that. I mean, for example, this length is range in 32 to 55. So you can choose this. You can design or decide the length because you are a designer. Yeah. So what do you choose the length? Yeah, he said the 40, right? Because 40 is the standard. And this we can use. We can find the 40 in R5 series of prepared values. Because this value is changed. Is green, long values. We make it 40 millimeter because 4 is in the R5 series of prepared numbers. Right? Just choose this length. This one. The layer. If you want to produce a set of layers with length between roughly 50 and 100 millimeter, then the application of the R5 series should lead to product a proper. This word you choose. 25. This is you mean that you choose 25. This is 20 to so many.
Oh, it's 16 and 25.
Yeah, 16 to 300.
15 to 300.
Millimeter.
We can see 16 to 451.
Right? It means that it's to multiply 10. So it's to 20, but 60, right? Right. 16, 25, 14. Yeah. 63. And then 100, right? Then this one 100 and 116, right? And 250, right? So it's in the range of 16 to 250, right? You understand? Follow you? If a file resolution is needed, another file numbers are added to the series, one after each of the original R5 numbers. So, and we end up with the R10 series. Could you write the word? R10 series prefield values. The series of prefield values contained R5. So this is one, another 5. This is eight. You have to see the table. Choose this series. Follow is R5 and end of R10, right? And five words, right? This is 1, 2, no, R10, and 1 after each the original R5 numbers, and we end up with R10 series. Another 5 numbers are added. This is the R10 and another 5. This is 5. You see this table. R10 is 1.25, 116, and 2 and 2 and 2.6, the 5 and 6 and 8 and 8 is 5. I don't think this is not right. Huh? 11. This breaks. Okay.
So the class that I seated, we have supposed to happen at 10:50, but because we came late.
Okay, you got a break, right? Okay, okay, we have a break. Let me to research to
Class that
11:10.
Yeah.
11:10, and we end our class at 12
Yeah.
or 12:10. 12.
Finish at 11:50.
11 finish 11:50. No.
Because you need more.
They were gonna finish the food.
Because our class is start at 8:30.
Yeah.
11:50. But start at 8:30.
Yeah.
I think next week.
Yeah.
Yeah. So
Teacher can say that the student, the student online is some.
But the student is.
According to the schedule, the schedule is not clear. So on the top, it starts at 8. But it starts at 8. Now you have to close at 12:30. Twelve ten.
Yes. Oh, but we start 8:30 and we still have we break.
So now today we are closing 12:10. We should not tell you.
Okay, it's time. You don't need this break.
Let's continue and finish at 11.
No, I don't know. Still is 12.
Let's continue and take the word.
If you take the break, it's 12:10.
Because that's not another class.
But
Let's
what
continue. Let's continue. There is some people here we need to go to school.
but it's confusing. It's a break. Okay. It's like
Why this class is great?
Why? This class, we are still here.
So every class.
Only class is it's so it should be
I thought it should be taken to which do everything.
Oh, yes.
Okay, can you check this number? 94. Oh, okay.
那个论天于是把论于是梦，好，不是那个是我们喜欢的那一个，这个是我的一个，这个不是我的，你是个人，你说我的，快点，快点。等一下。
Just check your message.
Okay, back to our class and end the class early, okay? Yeah, continue our class. So this is the, I think is the last content of this class, okay? If a file, if the file resolution is needed, is like me explained before, we just to design a smaller part. If the file resolution is needed, so we can use large, like the R10 or R20, R40, R80 series. So can to get very slow or very small range of this value and this value. Right. The 5 is a large range, large from this is the first number to second number. This is also the table. This is GB. Also is the ISO. It follows the ISO. So it's the ISO standard. So the R5 the values is large range. is 1.6, but R10 is finer. R20 is much finer. R14 is so many words in this previous values. You can choose much more the values. So if R14 cannot meet your question or requirement, you can use the R18. And another terms is derived series. So if the basic series, so this table is basic series, are not suitable, the requirements, the derived series can be used. The derived method is as follows: is R. This is I. This is B. Like example 10. I divide B. The B is the selected series value, like R5, R10 is the 5, 10, 20, 40, and 80. And I is the ith element of this series. For example, this is used like this one. We need to design a oil cylinder or piston. So this is the oil cylinder diameter. So this is the R10. We can design the values. The diameter value is choose. We can design the cylinder diameter. The diameter value is choose from R10 previous values, right? So the piston areas F is follow these rules. So we choose these areas from R10 divide 2. So 2 it means we choose the second one, like with the table. Is the R10. This is the one. The first one, and the second one we choose a word like this. I choose this one, and another is from here. One to choose this one, right? And one choose this one, and one choose this one. I'll take this one. This one. Yeah.
Can you go back? Actually, this R10 for. So it's the same thing.
Yeah, it's the same series values. You can choose the same, the same. So every 2 or every 4, you choose one. So like the R10, this one, huh? Formula.
The next one.
Yeah.
This is the B is the series, the basic series values. The I is the ith element of the series you choose. Yeah. So this is the R10 divided 3. You can choose. This is the first one. This 1, 2, 3. You choose 2. 10, 1, 2, 3, choose 4. 1, 2, 3, choose 8. The third one, the third, you choose the values. Yeah.
Actually, how are you in the count? How are you counting? I started with 0.
0?
And you said second in your one. Yeah.
The second, you can
Actually, how to count this
item.
I. That is started from 0.
Oh, you mean I?
Yeah.
I. No, 0.
That's from 0.
No, not for 0. It's 2, 3, 1.
1, 2, 3.
No, one is no 2 to 3. Is why just the to 10. It's just the B.
Also, this B is 5, 10, 20, 40, 80. And what about this I?
You mean how to define the I, right? This is the example. So like this, we can log to follow. The diameter is d. To measure this the side directly. We can to calculate. We can to use this
I understand.
value.
My question is, I understand what the I is. But when you account, when you go to the table. Alright, so yes, is that I1? That's I1.
For example, because the first serial, the first word we can get, let me this is the the first word we can give you. This is the first one. This is 1, 2 from this one.
So there's much more. So I'm asking
How to get
0,
I
1,
to
2.
table?
Right?
How to count the table, right?
How to get
Logic.
table?
Actually, this is 2.
Yeah,
This is 2.
yeah.
So it is 0, 1, 2.
No, this is the first word. Let me give you an example like this one. To write the first number is 4 because we can give you when we do the test. Okay, we can give you a number. Okay, the 4, the 1. The first number is 1. Is 1, and then follow to account 1, 2.
So
This is 1. We just give you some hint or information.
so if they say 2 or 5 is if it's 3.15.
If the first number is it, and then 1, 2 from follow this first number, and then to choose this one.
So the answer is 3.15 like that. Can you put that for
Question.
next to write 5 numbers according to arcane 2. So arcane, what's the answer for arcane? Arcane 3.
Arcane.
It's a 3.
Arcane is there 5. You just write the 5 numbers. Write the 5 numbers.
Only 3.15.
No, you write the numbers.
Yeah.
That's all.
1.25.
Okay.
So example this one is can every divided. This is wrong. I think I is yeah. 10, yeah. R10 RB divided I, yeah. It's R10 divided 3, right? Series. Okay. 10, 3. So is R10 this is the first one, right? 1, 2, 3. Choose this one. Is R10 divided 3. You can follow the rules to choose the number, right? Is R10. The first one is 1. The first one is 1. So it's 3. Okay, 1, 2, 3, 3. Okay. Here, you can choose this one. And then 10. Where? There. There.
Yeah.
1, 2, 3, choose this one.
How did you find the last time?
Last time?
Yes. Arcane.
Why not is okay. Yeah, you say
1, 2, 3.
Yeah.
Just this one.
Yeah.
Why can't you say 1, 2?
Because the first, you can give your hint, the first one.
It should always be an initial.
Huh?
You understand?
First one is
So
always
the
one.
first one is 1. 1, 2, 3. Now we are going to the second one. Your initial becomes 2. So 2
Oh.
so first,
You
and 1,
can
2, 3.
start with one.
It starts with an initial.
Oh.
You understand?
So if they say initially is the 4,
Now yeah, we start counting from the next.
1. That is
No,
not
you start, yeah, 1,
2,
2,
3.
3.
3.
Yeah.
Oh.
It's a very long time. You already passing.
This is the rules that you choose this. The ith element of this theorem.
但是刚才我写的 series 是1。
1, 2, 4, 8, 15. What? 1, 5. Okay. Can you? 10. 1, 2, 3. 1, 1, 2, 3, 2, right? 1, 2, 3, 4. 1, 2, 3 is 8. 1, this one is this one.
Okay.
This is 10, it's the same, it's green, right? This is 10, right? So it's 1, 2, 3, it's 200, 10. Yeah. Well, it's 10. Let me see, 8, 8 here, right? So 1, 2, 3 is 50, right? This one,
Oh, yeah.
10. This one is this one. It's this one. It's the same. Just to multiply 10, right?
Yes.
Yeah. So this
Yeah,
is
that's
6. Can you understand?
Yes.
15.
So it's the same from which angle? It's 10 and 1.
Yeah. The same.
From
Let me try to count. Bubbling in my head. So we have 1.
Huh?
So 1, 2, 3. Then we write this.
Yeah.
Then now we count.
1,
1,
2,
2, 3.
3.
Then we
Yeah.
write this.
Yeah.
Then this is your initial.
No, 1.
It's one.
So-
1. This
It's one also.
So
One.
1,
2, 3. Yeah.
Okay, then. Now this is your initial.
Yeah.
So 1,
One. No.
Oh,
it's
it's the same.
one.
Right?
2, 3.
Yeah. This is this one.
Okay.
This one. You can follow this rule. This is the rule. Follow this rule to choose this theorem.
Yeah.
Not joking. I mean, if you want to design a part, you just follow these rules. Choose the word. This is a series of the parts.
I think
Yeah.
we could try some examples.
Hmm?
Um,
Give you examples. Now the range. I remember the size is 8 millimeter. If the screw, do you know the screws? Do you know the screws diameter? This diameter. I remember that the 8 is very common to use, and the 16, and the 82. So no, that's large. And I mean, I just 8. I use it very. It's very common to use 8 and 10. Yeah, it's also common to use. And the 6 6? No. 4 is common use. Yeah. So all of this diameter is from this.
That's what I'm saying. Give us more example. Finding
The word, right?
yeah.
This is the exercise. You mean this one? Like this one?
What's the difference between this R10 divided by 2?
You mean R10 to R10, 20 divided
3. You can't 3, right? You can't 1, 3, right?
yes.
And what about R10?
I think you do count. You just put that count small.
The whole series of R10.
Oh, got you. You
When
could
you say to write 5 numbers.
So we just write 5 numbers after 1. First number is 100.
Let us do example number 3.
Let's start from 1. Let's do the example. Maybe after that. So the first number is 10, right? The 5 numbers going. Take.
this one, right? Give you these examples, and you can write this or follow the rest of these numbers. Okay. The first number is table is 10 R5, right? The first number is 10, and the first R5. The first number is 10, right? Is 10. R5 here, 5 is 10. This is the one. It's multiple. It's 10. 10 is here.
Yeah.
10 is here. It's the same. So this is
So it's
15. Yeah.
25.
Yeah. 5 numbers. You're right. Is 3, 20,
40, 60.
40 or
5 here.
What is it?
25, 40, 53,
and 100.
100. And then 1, 2, 3, 4, 5. 5. Just 5. Okay.
Why did you say start don't we say 1.6?
Huh?
Why don't we say 1.6?
1.6.
Start.
Yeah, the first number is 10.
I know.
Yeah, which should be.
Why do we say 16 instead of 1.6?
Because we started with 10.
You're only 10.
It's an extreme.
Now it's not.
So if we start from 1,
Huh?
if you start from 1,
Start from 1. Why?
yeah,
You because why it starts from 1?
No, because it is the first number is 1.
The first number is 1. The second is 1.6. Sure? The second one, you can write the second one. The first number is 100. Write 5 numbers according to R10 divided 3. Okay. 不够 question? Three, the first number
How many questions?
is 100, right? Okay.
yeah. It's
100, 200,
Yeah.
400,
Yeah.
800,
Yeah. And
This 101. Then 125.
no,
1,250.
1,060.
250.
160.
yeah,
660. Yeah.
160.
Oh, yeah. No. 1,600.
Yeah, got it.
360.
315.
200, 200, 400, 800, 1,000.
Yeah,
600.
No, because the 10 and the
Yeah, the one same ones.
So the first is 200.
Huh?
100. The first 206. No, the first is 100. The number starts from 100. 100 stuff.
Yeah, I mean the breaking the number.
Yeah, 200.
400.
The 10 is so it starts from 100. And it's
1, 2, 3.
1, 2, 3.
10, 100. You're very interested. Have this then. You have oh my. We don't have.
okay. So that one is right, someone else. Okay, to and explain it again. The first one is 100, right?
Yes.
This is arcane divided 3. Arcane is this different color, this color. Paint color. This color to choose the numbers. So the first is 100. The first is 100, and this is the third. The first one choose the number. This is 100. 1, 2, 3. This is 300, right? And 10. 1, 2, 3. 400, right? 1, 10, 2, 3. 800, right? This one is this one. 1, 2, 3. This is 1,600, right?
Yes. The 10 is the same.
Yeah. Because this is it's dream or now. Now wait. It's dream to limit. Unlimit. This one.
That's number is 1. 5,000.
This is I give you another table. The R, the mean that you get to write in the you can present it where it's the first one is 1, and this is it's very simple. The 10, 2, 23,
5,
5, 3.
I didn't see.
The question is just follow the numbers.
Yeah.
Follow the first one. First one is one. First number is 5 and write 5 numbers. The first number is 1. Write 5 numbers. The first oh you Okay, so I think all of you are right very well, but this one, and this one, maybe someone have little mistake. Okay, so mistakes, I mean. So the arcane is the same, is just one, yeah, 125. This one, yeah, and 126, then right, 1.6, and
2.5.
yeah, this one, and
R10
is 1.
1.6.
1.6, yeah, 1, 2,
2.5.
2.5,
4.
4,
6.3.
6.3, right? So this is, do you have some questions for this one?
Yes.
First one, do you have questions?
Like the first one, why the first one now is 1?
Why the first one is 1?
Yeah.
Because this give you hint. The first one, number is 1.
All of them.
Follow them, you can choose the, follow them, you can choose the numbers. The first number is 1.
Just contains the.
Continue with this, follow this first number. Do you have a question for the first, the question 1, question 2? Okay, so the question 3. Are 20 and 3, right? So the first one is 1 and 20. 20 here
Yeah.
and the 3, right? 1, 2, 3 is 1.4, right? And then
2.
yeah, 1, 2, 3 is 2.
Yeah.
And 1, 2, 3, 2.8, right?
Yeah.
And 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. And 1 is all.
It's okay, right?
45.
1, 2, 5. 5.6.
It's okay.
4 is okay.
Yes, you're right, Ocean.
And yeah. And R5 3. R5 3. So is first is 1. And second 1, 2, 3 is 4, right?
Yeah. 4.
And 1, 2, 3 is 16. 16, yeah.
16.0.
Yeah,
Yes,
16.
16.
1,
2, 3.
no, the 1,
63.
1, 2, 3.
63.
Yeah, 63, right?
Yeah.
And 1, 2,
2,
3 is 250, right?
Yeah.
Yeah. So this one and this one, someone have some mistakes.
I have a question now.
Yeah. Okay.
In the R5.
R5.
Yeah,
This one.
I want to know why we are saving 63 days.
See, why this is 63?
Yeah, because that R5 for me is the one that is not correct. This is 63 days. Why are we saying 63?
Why is 63?
Why is it 11?
So 63, right? 11 is this one, right? So is 3 is 1, 2, 3. It is 63.
She's asking why she's.
Why is not 6.3?
Why did it come to 6.3? Why? Because this is a series. Follow is 1. Follow 1, 2. Follow is extremely a large number, a large values. Like this color 5 is 1, 6, 6.3 and 10, and then dream of large values. It's dream large values that to multiply 10. It's like this, like this one. So it's R5 is multiply 1.6 is extremely a large numbers you choose. So this is 63. Okay, do you have questions?
Okay, last one.
Last one here. A question.
Yeah.
Actually, this is wrong. That is the true. First, I want to this one. Because this is the one, it's 4 numbers. According to 4, it's very simple. Okay. Table, okay. Question here. The first number is 0.01. R5 and the right 5 numbers.
It should be yes.
Yeah, yeah, it's right. Yeah. We know that. Yeah.
No, I think that it was.
Yeah, this is right. And yes, I should go to the last. Okay, the answer is what? 0.01 and 0.16 and 0.025, right? And 0.04, 0.063. Yeah. So that one. I think in this chapter, we just know the terms, the interchangeability, and the standard, and the series of preferred values. So this one just to you need to know how to check the table from the rules. Check the table. So that's all the content of the class.
Thank you.
You're welcome. Yeah, class is over.
同学们，下
下课吧。 He's lying. He's